All right, so for this next test, I gave you this review sheet to help you get ready. So I'm going to walk through these problems with you. So let's get started. So this first problem is one where we need to, first of all, I think it's easier to simplify everything, this fraction inside the parentheses, before we think about this power of 3. So I'm going to simplify the parenthesis, this fraction, everything that I can, and then everything that's going to be raised to the third power. So starting with this fraction 8 over 24, okay, you can reduce that by dividing by 8, and that's going to become 1/3. Okay, so for variables that match between the numerator and the denominator, we put those together as 1x using subtraction of the exponents. So 2 minus 6 would make -4. And then doing the same thing with the y's, y to the 7 minus 2 power would be y to the 5th. All right. And so now everything is going to be raised to the third power. So let's just go ahead and do that. Now everything that's being multiplied gets raised separately. So I really have three different things being multiplied together in the numerator. One is being multiplied times x to the -4, and that's being multiplied times y to the 5th. And so the rule says when I have this power of 3 on the outside of parentheses, I raise everything that's being multiplied to the power of 3. Well, 1 to the power of 3 is still 1. X to the -4 raised to a power of 3. This is where I multiply exponents together. So that's going to make x to the -12. And then y to the 5th raised to the 3rd makes y to the 15th. And then I also have to raise this 3 down in the numerator, in the denominator, to the power of 3. So 3 to the 3rd is 27. So I'm almost done. The only problem is we've said in the past you never want to leave an answer with a negative exponent. And so to fix that, x to the -12 in the numerator can be changed to x to the +12 by moving it down to the denominator. All right, and if you put 1 here in front of y to the 15th, that would be okay, but we typically don't show a coefficient of 1. So that's it. That's my answer for that first problem. The second problem is very similar. It's just that I'm going to have a negative exponent on the outside, but the first thing I'm going to do is simplify the parenthesis part as much as possible. Well, I have 6 over 1, so can't really do much with that yet. I do have two different a's. A to the 5th being divided by a to the 1st makes a to the 4th. And then b to the 4th divided by b to the -2. Remember, you're subtracting exponents, so b to the 4 minus -2 makes b to the 6th. And then we basically just have 1 as the denominator, and then everything's going to be raised to the -2. So remember, negative exponents like this tell me to look at the base, which is the part that's in the parentheses, and the negative exponent says to flip that base over. So you literally just take the numerator and the denominator and switch them. And after doing that, then you can make the exponent positive. And so now I'm going to apply that same rule that I used back over here in problem 1. Everything in the parentheses is going to be raised to the second power. So 1 to the second is still 1. 6 to the second is 36. A to the 4th raised to the second, I multiply exponents, and that's a to the 8th. B to the 6th raised to the second, multiply exponents again, and that's b to the 12th. And that ends up being my final answer. Okay, so for number 3, remember, according to PEMDAS, we have multiplication in this problem, and we have exponents. We need to take care of exponents before we jump to multiplication. So what that means is I'm going to have to go ahead and take care of raising a times b to the negative third before I jump to multiplication. All right, so I'm going to just bring down 4 times a to the negative 2, b to the 7. And when I use that rule that says whatever's being multiplied in parentheses raised to a power means both of those variables are going to be raised to the power. All right. And now I'm going to multiply. So if you want to think of it like this, I'm going to have a coefficient of 4 times a coefficient of 1. So 4 times 1 is 4. And then for the variables that match, when I multiply, I add exponents together. So it's like a to the negative 2 plus negative 3 power, which makes negative 5. And b is going to be to the 7 plus negative 3 power, which is 4. So the only one of these three terms, the constant and the two variables that need changing, is this a to the negative 5. So 4 times b to the 4th remain like they were, but to fix this negative exponent, I'm going to send it down to the denominator, and then it changes the exponent to positive. There's my answer for number 3. Okay, so going to 4, 5, and 6. I'm going to simplify first by doing the distributive property. So when I multiply 5xy times 2x, I get 10. 5 times 2 is 10. The two x's multiplied together make x to the second. Remember, you're adding exponents. And then you just got this lone y that there is no other y with the 2x term. So that takes care of distributing 5xy times 2x, and now I'm going to distribute 5xy times negative y. Well, it's 5 times negative 1. That makes negative 5. X times 1, I guess you could say, is x. Y times y makes y squared. All right? And now I'm going to jump over here and distribute 6y squared to both of these. So 6y squared times x squared is 6x squared y squared. Notice when there's two variables in a term, you just list them alphabetically. And then 6y squared times 6 is 36y squared. And now I'm looking for like terms. Like terms have to have the same variables in them, and those variables have to have the same exponents. Well, looking at this problem, the result, I don't see any like terms. There are no terms that have same variables with same exponents for the variables. So that ends up being my final answer for number 4. Number 5, when I multiply two binomials together, this should be a review for you. This is just the FOIL method. So first terms multiplied together, that's n squared. Outside terms multiplied together, n times 7 positive makes plus 7n. Inside terms, negative 9 times n makes negative 9n. And then the last terms, negative 9 times 7 is negative 63. And then you just combine these terms in the middle, the like terms, and 7n minus 9n is negative 2n minus 63. There's my answer. This is a subtraction of polynomials problem, so I like to distribute negative 1 to this second polynomial, drop the parentheses, and with the distributive property. So negative 1 times 3x squared is negative 3x squared. Negative 1 times x is negative x. And negative 1 times negative 1 is positive 1. And then I'm going to combine like terms. So x squared minus 3x squared is negative 2. 1 minus 3 is negative 2x squared. Negative 5x minus 1x is negative 6x. And then these constants, 2 plus 1, make 3. All right. Jumping to number 7, allow you to choose either Pascal's triangle or the binomial theorem. So I guess I'll work this one out in both ways, or at least I'm going to work it out using Pascal's triangle. So make sure you understand how to make the triangle. And then I'll show you how the binomial theorem could be used, and it's very similar. Okay, so to use the triangles, I noticed that the binomial is raised to the 5th power, so I went to the row of the triangle that has 6 numbers. Remember, when you're done, you should end up with 6 terms. So this is the row of the triangle that will be needed. So to use Pascal's triangle, I take the first number from the row, which is 1, multiply times the first variable in the parentheses raised to, in this case, the 5th power, whatever the binomial is raised to. And then the second term in the parentheses will start off at the 0 power. All right, now the next term uses the next number from the row, and n is going to drop down to the 4th power. -6 is going to go up to the 1st power. Then the next term will use 10, the third number. N drops down to the 3rd power. -6 goes up to the 2nd power. All right, the next number in the row is also 10. N drops down to the 2nd. -6 goes up to the 3rd. Next number in the row is 5. N drops down to the 1st. -6 goes up to the 4th. And then finally, 1 gets multiplied times n to the 0, and that gets multiplied times -6 to the 5th. All right, so here we go. That's showing our work. And now let's go ahead and clean this up, simplify to come up with our final answer. So the first term, when we multiply all 3 of these together, -6 to the 0 is 1. So 1 times n to the 5th times 1 makes n to the 5th. Okay, the second term, I'm going to be multiplying -6 times 5, and that makes -30 n to the 4th. Okay, the next term, I have to do this power. -6 to the 2nd power makes 36. And then I'm going to multiply that times this 10. So 36 times 10, and it's positive. Raising a negative number like -6 to an even power makes it positive. So 10 times 36 is 360. And then the variables are n to the 3rd, or the variable is n to the 3rd. All right, moving on to this 4th term, I have to do -6 to the 3rd power first. So putting in -6. Now make sure you put -6 in parentheses if you're going to trust your calculator to give you this answer. And that's -216. All right, so maybe change some color here. -216 is -6 to the 3rd power, and now I got to multiply that by 10. So that's going to be minus 2160 n to the 2nd. All right, now I'm ready to work on the 5th term. So this time I'm going to raise -6 to the 4th power, and that's 1296. Okay, so doing -6 to the 4th is 1296, and now that needs to be multiplied times 5. 1296 times 5 is 6480, and it's going to be plus 6480 n. And then my last term, simplifying all of this, 1 times 1, n to the 0 is just 1. So all I have to do to get this last term is let my calculator tell me in parentheses -6 raised to the 5th power. And that's negative, so this is going to be minus 7776. So for subtraction in the original problem, the sign should always alternate back and forth. Now the first term is positive, but then after that it should always go minus, plus, minus, plus, minus, just like this. They should just alternate back and forth. So if you chose, I'm not sure if anybody would choose, but if you did choose to use the binomial theorem, then in order to get these coefficients, I'll just do a couple, you would show me this. You would instead of getting 1 from the triangle, you would get 1 by calculating this combination, 5, because that's the exponent for the binomial, C, and then you start with 0. So if you went to your calculator and did 5 NCR0, you would get 1. Everything else is the same. Nothing else changes between the two methods. It's just a different way of coming up with this this coefficient that we're multiplying by that we got from the triangle. So this next number, 5, you would get it by calculating 5C1. So if you choose to do the binomial theorem on the test, you would need to show me these and then get to your final answer. All right, so to get 10 using the binomial theorem, you would not go to the triangle, of course. You would calculate 5C2. So you start at 0, and then this right number just goes up by 1 each time. And that's just a different way of getting those coefficients that came from the Pascal's triangle. All right, so this ends up being the final answer. I'll go ahead and circle it. And let's move on to number 8. Number 8 is a binomial theorem problem. Please don't give me all 10 terms and then circle the 9th one. We learned a way to just come up with the 9th term. So the binomial theorem is basically going to be set up like this. 3 different expressions, terms, are going to be multiplied together. One of them will be a combination that you'll calculate in your calculator. So the combination is going to look like this. 9 will be to the left of C because that's the power of the binomial. And the number to the right of C will just be 1 less. So I'm looking for the 5th term, so always make this number to the right of C be 4, 1 less. It'll always be 1 less. And here's something else that's always true. This second number, the number after C, should always match this second exponent. They should always be the same number. Okay? Well, if you understand that, there's 2 ways of coming up with this exponent. Either do the difference between these 2 numbers, which is 5, or just remember that these 2 exponents, when added together, should equal the exponent that's showing in your problem. So in this case, my binomial is being raised to the 9th, so these 2 exponents have to add up to 9. All right, so in the parentheses, I'm putting this first term, 4a, and it's going to be raised to the 5th, and then the second parentheses, I'm going to put 3b, the second term. And now it's just a matter of letting your calculator come up with 9c4, so 9 NCR 4 is 126, and 4 to the 5th power is 1024, a to the 5th, and 3 to the 4th power should be 81, and b to the 4th. So now these numbers need to be multiplied together to come up with our final answer. We know the variables are going to be a to the 5th, b to the 4th, but we need to multiply 126 times 1024 times 81. And that's 10450,944. A to the 5th, b to the 4th. Okay, and that's our answer then for number 8. Okay, problem number 9 is another application of the binomial theorem when we have probability problems that involve 2 possible outcomes. There's only 2 possibilities for a pitch. It's either a ball or a strike. So just as likely to throw either means there's a 50% likelihood of both. So just write down your 2 percentages of the 2 events taking place and just label them. Really doesn't matter which one is which. Excuse me. And these will be raised to a power, and eventually they'll be multiplied together. And since we're doing the binomial theorem, then we're going to have a combination that's going to be a number that is a combination that will be multiplied times both of these. Okay, so we've got the probabilities. Find the probability that 7 of her first 12 pitches are strikes. Okay, so I'm going to take this probability that I have labeled as strikes, and I'm going to raise it to the 7th power. That's what the problem wants to know. If it had said 9 of her first 12 pitches are strikes, I would be raising the strikes probability to the 9th power. Okay, so if I throw 12 pitches and I make 7 of them strikes, then that means 5 of them must have been balls. Okay, so the combination is going to be the total number of pitches, which is 12. And remember what I said about the previous problem, whatever this second exponent is, should be the number that follows C. They should always match. Okay, now let's go to our calculator and we'll do all of this let our calculator come up with the number. So 12 NCR 7, and then I'm just going to say times, and I'm going to raise 0.5 to the 5th power, times, and then I'm going to raise 0.5 to the 7th power. And what shows up in my calculator is 0.193359375. So that's the decimal form, but I want you to put this in percent form. So either slide the decimal 2 places to the right, or you could leave this decimal in your calculator and do times 100, which accomplishes the same thing. And since we're told to round to the nearest hundredth, that's the second decimal place. So it says 19.335. So I'm looking at the 5, and that tells me to make that second 3 go up by 1. So this would be my final answer, 19.34%. Okay, let's do a couple of long division problems. So I'm dividing x minus 5 into 3x cubed minus 16x squared plus 9x minus 24. So with long division, I'm dividing first term into first term. So it would look like this, 3x to the 3rd divided by x, and that makes 3x squared. And now I multiply 3x squared times both of these. 3x squared times x is 3x to the 3rd. Erase that little. Okay, so we found out that x goes into 3x cubed, 3x squared times, and now we multiply 3x squared times both of these terms. And with long division, we always subtract. 3x cubed minus 3x cubed is 0, and now I have to be careful here. It's negative 16 minus negative 15, which is really adding. So negative 16 plus 15 is 1, negative 1, x squared. Bring down the next term, and now divide x into negative x squared. If it helps, you can go off to the side and literally see it. Negative x squared being divided by x would give you negative x. And now multiply negative x times both of these. Negative x times x is negative x squared. If you do it correctly, these two terms should always become 0. And then negative x times negative 5 is plus 5x. Set up subtraction again. So the x squares cancel out. 9 minus 5 is 4x, and then bring down the next term. And now we've got one more division to do. This time we're dividing x into 4x, and that goes positive 4 times. And when I multiply 4 times x minus 5, sorry, I'm way down on the sheet here, but I'll just rewrite this. So here we are. when I multiply 4 times x minus 5, I get 4x minus 20. So the 4x's cancel out. Negative 24 plus 20 is negative 4. So when I have a remainder like this, I show it as, since it's a negative 4, I'm going to do minus, and then I'm going to put 4 over what I divided by, which is x minus 5. So that, I'll circle this as my final answer. Okay, let's do another long division problem. So we'll set this up. Always be aware of making sure that your exponents go in order and that you're not skipping over exponents. That's always important. We're not in this case. So we start with x to the 4th minus 4x to the 3rd minus 7x squared plus 34x minus 24. Okay, so the first term, x squared, divides into the first term, x to the 4th. And x to the 4th divided by x squared is x squared. Now I'm going to multiply x squared times each one of these three. So x squared times x squared times negative 5x, x squared times 4. Subtract. The x4's become 0. Negative 4 plus 5. Notice we're subtracting negative 5, so negative 4 plus 5 is 1, x cubed. Negative 7 minus 4 is negative 11, x squared. And then I'm going to bring down my next term. Notice I'm dividing by 3 terms, so I should have 3 terms here that I'm dividing into. So x squared divides into x cubed x times. And now I distribute the x times all 3 of these. Minus 5x squared plus 4x. Subtract. X cubes cancel. Negative 11 plus 5 is negative 6, x squared. 34 minus 4 is 30x. And bring down the minus 24. And let's do one more. X squared divided into negative 6x squared goes negative 6 times. Now multiply negative 6 times each one of these. Negative 6x squared plus 30x minus 24. If you subtract, I'm out of room, but you should see that we're going to have a remainder of 0. So this ends up being the final answer. So do you have any questions about long division before I move to synthetic division? Any questions? Okay, synthetic division. The first thing I need to do is observe what number could I plug in for x to make this binomial become 0. That's pretty important because if you choose the wrong number, you're going to get this problem wrong. So negative 3 is the number that I would plug in for x. So that's the number that we say goes in the house. And then to the right of negative 3, I'm going to write 2, 3, negative 4, and 15. The coefficients and the constant of what I'm dividing into. Okay, so remember there's never a number right here. This is just white space always underneath this first coefficient. So I bring down that first number and then I multiply. The number under the line times the number in the house. 2 times negative 3 is negative 6, and then I add. Now I'm going to multiply negative 3 times negative 3, makes 9, add those. And I multiply finally 5 times negative 3, that's negative 15, and that makes 0. So to interpret these numbers, this is always remainder. And these numbers represent coefficients and constant. And how I know what they're the coefficient of, since I divided into third degree, x to the 3rd, this has to be in front of second degree. It's always going to be 1 degree less. And so since that's x to the second, this has to be in front of x to the first. And that means this will be my last x, which makes 5 a constant. So there's the answer for number 12. Number 13, I'm going to put positive 3 in the house. And then 3, negative 5, negative 23, positive 24. Be careful that you don't skip over, but we don't in this case. 3, 2, 1, constant. Bring down the first number. 3 times 3 is 9. Add. Always add with synthetic division. 4 times 3 is 12. Add those. Negative 11 times 3 is negative 33. Add those. Now my answer is going to be, since I divided into third degree, this is going to be second degree. 3x squared plus 4x minus 11 minus, and to show the remainder, I'm going to put minus 9 over what I divided by, x minus 3. So on your test, be ready for 2 long division and 2 synthetic division problems. Any questions about synthetic division? Okay. I'm also going to see if you understand the fundamental counting principle. What are permutations and what are combinations? So we have one of each. Well, this first, and please don't think on the test that they're going to be in the same order as what they are here. So don't just automatically assume that when you get to this section, this first one is going to be fundamental counting principle, because it was on the review. These are going to be mixed up. There will be 3 of them, I can tell you that, but they won't necessarily be in this same order. So you're going to have to understand what makes a problem so that I have to apply the fundamental counting principle. Well, the thing that gives number 14 away is I'm giving you all of these different options. Notice there's bikes are broken up into different speeds, different colors, different sizes. So this is how we use the fundamental counting principle. We take the number of choices within each option, and we basically just multiply those numbers together. It's pretty simple. 2 speeds, 5 colors, 4 sizes, multiplied together. There are 40 different types of bikes. Number 15, notice we have 10 toppings that we could put on our yogurt. We just want 3. Okay, so looking at all 10, choosing just 3, how many different 3 topping choices can I come up with? Well, the thing you should ask yourself in these problems is, am I putting these toppings in a certain order? I mean, does it matter if I choose, I don't know what the toppings are, chocolate chips, coconut, whatever? Does it matter that I have to choose them in a certain way? It does not. No. So permutations are all about putting items or people in order. There's a first person, that means there's another person in a second spot. There's another different person in a third spot. That's what permutations are all about. If order is irrelevant, if all I'm doing is choosing a small group of choices, 3 in this case, out of a big group, that's a combination. So I'm going to go to my calculator and I'm going to evaluate 10C3. I got 10 total choices, and I'm only choosing 3 at a time. So make sure you understand how to get to that in your calculator. I'm going to do the same thing. So do we agree that that's 120 choices? 120 different ways. I'll just say it like this to make it in context: different 3 topping sundaes. Make it match the wording in the problem. So number 16, notice this time I've got to choose a president, which means there's got to be a different person in this spot as vice president. I can't have a person occupying both of those spots. Then there's a different person that's going to be chosen as a secretary. And then there's another different person that is chosen as a treasurer. So usually you can tell permutation problems because there's a ranking involved. The president is kind of like the first person in power. The vice president would be the second person in power. So if you identify that there's a ranking here, also identify that you can't have two people occupying the same spot. That's not true here. It doesn't matter if chocolate chips are first, second, or third. Doesn't really matter for combinations, but it does matter here. So this is what permutations are all about. So I got 15 total members to choose from, but I'm only selecting 4 offices. So this time we're going to do 15P4. And 32,760. Is that what you got? 32,760 ways to choose officers. Okay, so do you have any questions on how to distinguish between permutations and combinations? That's usually the struggle that people have. Any questions? It's all about whether you're arranging, ordering, listing, ranking, or not. That's what it really boils down to. All right, now we're going way back, and the purpose for this is I know what's coming next week, and you're going to see this same thing next week. So you've got one of these on your semester exam, so let's kill 2 birds with 1 stone. We'll do a little semester exam review while we're getting ready for this test. So what I want you to know is that 2 lines that are parallel have the same slope. And the slope of this line that's given is 4. So that means the slope of this line that goes through 10, 2 is also 4. So if I'm writing an equation that represents a line for us, that means y equals mx plus b. So this point that I'm given tells me what x and y will be in this equation. And I already found out what m is, so really this just amounts to finding b. Let's find b, plugging these numbers in. So y is 2, m is 4, x is 10. Let's solve for b. So it looks like when I subtract 40 from both sides, b is negative 38. Okay, so now this was real generic. Now I'm going to get it specific to this particular problem to get my final answer. Just plug in m and b into the slope-intercept form, and you've got your answer. Okay, questions about writing linear equations? Now on your test, you don't have to worry about the perpendicular version, but on your semester exam, you could. So we'll save that for next week in that review. All right, so quadratic formula. On your quiz that we took, I gave you the quadratic formula. On the test, I'm not. So I'm going to expect you to know what the quadratic formula is. So here it is. Usually when people miss these, they forget this. So don't forget that there's plus minus built into the quadratic formula. It's already ready. It's set up because it equals 0. So A is going to be 2, B is going to be negative 3, and C is going to be negative 4. So I just plug those numbers in, and then we're ready to go. So it says, the formula says the opposite of B. That's the opposite of negative 3. That's positive 3. Plus minus. Under the radical, it says b squared. Well, negative 3 squared is 9. And still under the radical, I'm multiplying 4 times a, which is 2, times c, which is negative 4. All of this, the whole thing, is going to go over 2 times 2. Remember, a is 2, so 2 times 2 is 4. So I'm going to work on putting all of this together under the radical and then seeing if I can simplify the radical. So multiply all these together and you get negative 32. 4 times 2 is 8. 8 times negative 4 is negative 32. So I'm just going to come down and I'm going to say 9 minus negative 32, just doing it a little step at a time. So I went from here to here just by simplifying what was in the brackets. All right, and now subtracting negative 32 is really like adding. And there is no way to simplify the square root of 41 because none of my perfect square root numbers divide into 41. If one of them did, then I could simplify, but unfortunately I can't. So this ends up being my final answer for number 18. All right, questions on 18? All right. What is the equation for the axis of symmetry? Well, here is the formula to find that number. So going back to chapter 3, opposite of b over 2a. Once again, a is 1, b is negative 4. So it's the opposite of b, which is negative 4, over 2 times a. So in the parentheses, negative 4 divided by 2 is negative 2. But the formula says write down the opposite of that. That'd be positive 2. So the equation for the axis of symmetry will be x equals, always going to be x equals something. In this case, it's 2. What is the vertex? Well, I know what part of the vertex is because the AOS and the x-coordinate are the same. So all I have to do to find the y-coordinate of the vertex is to plug 2 in for x. Let's see what comes out. So 2 squared is 4. All right, 2 squared is 4 minus 4 times 2, which is 8, add 7. 4 minus 8 is negative 4. Negative 4 plus 7 is 3. So the vertex is the point 2, 3. So just keep in mind that when you find the AOS, you've already found the x-coordinate of the vertex. So just plug that number in. Does this function have a maximum or minimum value? Well, it depends. Can you identify how the parabola opens? Well, that's all about what a is. If a is positive, then it opens up. Obviously, then if a is negative, it opens down. So in this case, we're not dealing with this situation. A is positive, so the vertex is at the very bottom of this parabola, which means we're going to have a minimum. It's all about where the vertex is. And we've already found the value. You found the value when you found the y-coordinate. So minimum value of 3. All right, on these last two problems, we are reviewing the number I and operations involving the number I. So number 20 is, since we're multiplying two complex numbers, think of it in the same way as multiplying two binomials together. We always use FOIL in problems like this, so that's how we're going to come up with the answer for number 20. So the first two numbers multiply together, 3 times 4 is 12. Then I jump out to the outside two numbers, 3 times 3i is positive 9i. On the inside, we do negative 2i times 4, that's negative 8i. And then the last would be these two. Negative 2i times 3i makes negative 6i squared. Okay? Just remember that in addition to knowing that I is the square root of -1, we've learned that. Well, another truth that comes out of that statement is that I squared is -1. We get this because if we just take the original I definition and raise both sides to the second power, we get this. So anytime you see I squared appear in a problem, like it does here, we need to substitute -1 in its place. So combining like terms, 9i minus 8i is 1i. And then I'm just going to go ahead and literally show what's happening. I replaced I squared with -1, like we said earlier. And now I'm going to multiply -6 times -1, and that makes +6, +6. And now to finish off the answer, this is going to be a complex number. The real number part of the complex number will be 12 plus 6, which is 18. So a complex number is always written in this way. It has two parts. It has a real number part, which is in this case 18, and then of course it has the imaginary part, which is pretty obvious. But it is important that you put the real number first when you write the complex number. So there's my answer for number 20. Our last problem involves simplifying the square roots of negative numbers, but we're going to use the number I to make that happen. So what I need to do is change the square root of -25, simplify it. So if I'm using factoring, I would say that's the square root of -1 times the square root of 25. Both of these radicals can be simplified because, again, going back to the definition of I is the square root of -1. And we already know, hopefully, that the square root of 25 is 5. So to put all this together, I'm rewriting the square root of -25 as 5i. And notice in the problem, 6 is being multiplied times the square root of -25, so it still should be multiplied here. I get some people that do other operations, but those are still being multiplied together, and I'm going to bring down the -4. So I always do multiplication before I do subtraction. So 6 times 5i is 30i. And the only problem now is, going back to what we said earlier, this is not in the correct order. The real number should always go first in a complex number, followed by the imaginary number. Now it's in the correct order, and that is my final answer. So those are the problems that I'm going to test you on, and I hope this review sheet helps. I hope you work these problems out many times, as many as needed, so that you'll come in on test day and be very prepared for what you're going to see. So if you have any questions, let me know.